Hello, in this video we are told, find the sum of the squares of all integers from 1 to 1000. So basically what we need to do is find 1 squared plus 2 squared plus 3 squared all the way to 1000 squared. If you were to do this by hand, you probably take a couple of hours. What you are going to do in the video though is we'll try to find a general formula for this kind of situation. Now, in the previous video, remember that we were looking for the sum of all integers from 1 to n. Today, we are looking for the sum of the squares. So previously, for the sum of all integers from 1 to n, that is 1 plus 2 plus 3, all the way to n, we said that it's the same as just doing n times n plus 1 over 2. So this is the formula to find the sum of all integers from 1 to n. Now this formula is going to come in handy a bit later, but for now I want to introduce a new concept, and the concept is the summation symbol. Now consider this sum of all integers from 1 to n, so 1 plus 2 plus 3 all the way to n, right? That's the same as me coming here and writing, I want you to find the summation where k is equals to 1. K is just, a random variable. And then, so we are finding the summation where k is equals to 1 all the way to n of k. So now I can scroll up. This means when k is 1, the value here will be 1. And then since this is the summation symbol, it means that the connection between one term and the next is the plus operation, right? So when k is 1, this is just going to be 1. When k is 2, this is just going to be 2. When k is 3, this is just going to be 3, all the way to when k is n. Now, let me give you another example so that you understand. When I tell you to find the summation from k is equals to 1 all the way to k is equals to n of 2k, this is going to be, we start with the first term. So when k is 1, this is going to be 2 times 1. Then plus, when k is 2, this is going to be 2 times 2. Then plus, when k is 3, this becomes 2 times 3. And this is going to happen all the way to when k is n, and this is going to be 2 times n. So this is basically what I mean. So in this case, if we just expand this for the sake of it, 2 times 1, that's going to be 2, plus 2 times 2, that's going to be 4, plus 2 times 3, that's going to be 6, plus all the way up to 2n. So you see, when you say the summation from k is equals to 1 up to k is equals to n of 2k, you are getting the summation of all even numbers. Okay, let me show you another example. Once you understand this concept, the rest of the video is going to be way easier. So another example is, when I tell you to find the summation from k is equals to 1 all the way to k is equals to n of something like 2k minus 1, what do you do? Right? So you just come in and plug in. For the first term, we are doing k equals to 1. So when k is 1, we are going to have 2 times 1 and then minus 1. So this is the first term, and we've said since we are summing, the connection between one term and the next is the plus symbol. So when k is 2, this becomes 2 times 2 minus 1, right? When k is 3, this becomes 2 times 3, then minus 1. And this will happen all the way until we get when k is n. So when k is n, this is going to be 2 times n minus 1. And then let's just also expand this. So 2 times 1, that is 2, minus 1, that's going to give you 1, plus 2 times 2, that is 4, minus 1, that's going to give us 3. Then plus 2 times 3, 6, minus 1, that's going to give us 5. Plus all the way up to the last term, which is going to be 2n minus 1. So you see, in this case, when we are summing from k to 1 all the way to n of 2k minus 1, we are basically saying I want you to sum all the odd numbers from 1 up to n. So you see the gist of the thing. Now, one final example, because this is our main interest. Now, if I tell you I want you to sum from k is equals to 1 all the way to k is equals to n of k squared, what is this? So when k is 1, this becomes 1 squared. Then plus, when k is 2, this becomes 2 squared. Then when k is 3, this becomes 3 squared. And this is going to happen all the way till k is equals to n. So when k is n, this is going to be n squared. Now, this is our interest because it's the same as this. So we are doing 1 squared plus 2 squared plus 3 squared all the way to 1000 squared. So in our case, the general case is just up to n squared. Now, once you remember that, you'll be good for the rest of the video. Now, let's get started, and we are going to start from a place that you know, right? You know how to expand an algebraic expression. So when I give you k minus 1 cubed, what do? You come and say, this is the same as doing k minus 1 times k minus 1 times k minus 1. So k minus 1 cubed is basically k minus 1 times itself 3 times, right? So I know this seems a bit unrelated to our original question, but just hold on. Let's start with these last two terms here, right? So we still have this first term, k minus 1. So let's expand these last two. So k times k, that's going to be k squared. Then k times negative 1 will be negative k. Negative 1 times k, that will give you negative k. Then negative 1 times negative 1 will give you plus 1. So what does this become? So this becomes k squared minus k, that is the same as minus 2k plus 1. Then, of course, we have this first term and we have the equal sign. Now, let's expand this further. So, k times k squared, that becomes k to the power of 3. K times negative 2k becomes negative 2k squared. K times positive 1 becomes positive k. Then, negative 1 times k squared becomes negative k squared. Negative 1 times negative 2k becomes positive 2k. Negative 1 times positive 1 becomes negative 1. So let's simplify this. So this becomes k cubed. Then here we have minus 2k squared. Then here we have minus k squared. Okay, then here we have this plus k, and then here we have plus 2k. And finally, we have minus 1. So we've just collected the like terms together. Now, what does this become? So we have k cubed, and then minus 2k squared minus k squared becomes minus 3k squared. Then k plus 2k becomes plus 3k, and then we have minus 1 at the end. Now, this is on the left side of the equation. Remember, we still have k minus 1 cubed. Now, at this point, obviously, the left side of the equation is identical to the right side of the equation. So that means we can rearrange these terms. What I want us to do is, we are going to take this k minus 1 cubed term, and we are going to take it to the right side. And then we are going to take these other terms here, the ones on the right. We're only going to be left with k cubed on the right. So all these other terms, we are going to take them to the left side. Now, when they come to the left side, negative 3k squared becomes 3k squared. It becomes positive. Positive 3k becomes negative 3k. k. -1 becomes +1. Up to that point we are clear. Now we are saying this is all equals to, on the right we had k cubed, and now we have brought this k minus 1 cubed term to the right. So when it comes to the right, it becomes negative. So minus k minus 1 cubed. So you see, we haven't done anything crazy so far. All we have done is we've expanded k minus 1 cubed, and then we've just rearranged the terms. Okay, now the next thing I want you to do is, let's write this equation starting like with the terms on the right. So basically this implies that k cubed minus k minus 1 cubed is equals to 3k squared minus 3k plus 1. That's okay. We've just, exchanged the sides of the equation. Now, what I want us to do at this point, we need to introduce the summation symbol, the one we have just learned here, right? Remember? Now, what we are going to do is, we are going to introduce the summation on both sides of the equation. So we are going to say the summation from k is equals to 1 all the way to n of this left side. So we're just going to use the square brackets here. So the left side is k cubed minus k minus 1 cubed. This is equals to, then on this other side, we also introduce the summation, and it's the same summation. So k is equals to 1 all the way to n of 3k squared minus 3k plus 1. You see, we've only introduced the summation. Don't worry about this left side. Don't let it scare you. In fact, it's the easiest. Now, what we need to do next is realize when I tell you to sum, for example, what we have on the right, you see we have the summation operator outside, and then inside we have 3k squared minus 3k plus 1. So those are the terms. This is the same as just introducing this summation operator to each one of these terms, right? So this means, okay, let's start with this left side. So the left side just remains the same. So we have the summation where k is equals to 1 to n of this whole thing. So k cubed minus k minus 1 cubed. This is equals to, now we introduce this summation to each one of these terms. So this is the same as doing the summation from k is equals to 1 to n of the first term, which is 3k squared. And then the operation here is minus, then we sum that other term, minus the summation from when k is equals to 1 all the way to n of 3k, and then plus the summation from when k is equals to 1 all the way to n of this one here, right? So this, when you are summing and you are summing a bunch of terms, it is just the same as introducing the summation to each of the terms. Okay, another thing to know is that when you are summing and you have a constant here and then the variable itself, this is the same as taking the 3 outside and then summing the k squared. So this becomes, we still have the summation k is equals to 1 all the way to n. Let's take the 3 outside. So this is the same as 3 times the summation of, now in the inside we only left with k squared. So these two are identical, and then minus, we do the same thing here. We take the 3 outside, and then we have the summation from k is equals to 1 all the way to n, and now in the inside you're only left with k, and then plus this other one, it's just a constant, so there's nothing to take out, nothing to leave, so we just have it as the summation where k is equals to 1 all the way to n of 1. And don't forget about the left side. So the left side has not changed yet. K is equals to 1 to n of k cubed minus k minus 1 cubed. Okay, so now I want you to notice something here. Let me change the color. In fact, you see this summation of k squared here. Is that not what we are interested in? Remember, we had k, it's the summation from k is equals to 1 all the way to n of k squared. And we are summing, so this is identical to 1 squared plus 2 squared all the way to n squared. And that is our interest, right? So that's something to note. This is what we are interested in. Then another thing to check is, look at this. Have you seen this somewhere? The summation from k is equals to 1 to n of k. Let's go back here. Scroll a bit upwards, and here it is. The summation from k is equals to 1 to n of k. This is 1 plus 2 plus 3 all the way to n. But we already determined that, let me scroll a bit here. We already determined that 1 plus 2 plus 3 all the way to n is the same as we use this formula, n times n plus 1 over 2. So we go back here. So we start from where we know. We know that we have this. Let me change the color back. We know that we have negative 3 times, and then all this summation is now this formula, right? So this becomes negative 3 and then times n times n plus 1 over 2. So that's just basically the same as writing those terms here, all over 2. So this collapses to this. Now let's talk about this other one. Now this other one, let me scroll to the right, and we are going to try and write out what it means. When I give you the summation of k equals to 1 all the way to n of 1, what does this mean? When k is 1, this is still 1, plus when k is 2, this is still 1, plus when k is 3, this is still 1. And this is going to happen all the way to n. When k is n, it will still be 1. But this is like taking 1 n times. So this is the same as doing 1 times n, which is n. So this summation is just doing n, right? So we come back here. And now we are saying this last term is just the same as doing plus n. And that's it. Now, we still have this k squared, of course. So we write it. And in fact, this minus, let's just have it for the whole term. So I'm going to do the minus here. And then we are going to have that summation of k squared, k equals to 1 all the way to n. We have the 3, and we are saying all this is equals to the summation k is equals to 1 to n of k cubed minus k minus 1 cubed. Okay, so the right side is looking good. We'll just have it as is for now. Now let's focus on this left side. This is the most interesting one because it looks very complicated, but it's literally the simplest. What we are going to do here is we are going to write the first, let's say 5 terms, or rather 4. Let's go with 4. We are going to write the first 4 terms of this summation, right? So we are going to say here I have the current value of k, right? Since we have interest in that, and we've said we are going to do this for the first 4 terms. So this means k is going to come to go from 1 all the way to 4. So we know that our value of n is 4, of course, but this means that we are going to have values for when k is 1, when k is 2, when k is 3, and when k is 4. Nice. So that's that. On this other column, we are going to calculate the value of like the inner expression k cubed minus k minus 1 cubed, right? And then finally, after all that, we are going to now find the summation. So we are just going to have the sum of the first n terms. Okay, let's start with the expression. So when k is 1, this expression becomes 1 cubed minus 1 minus 1 to the power of 3. So this is the same as 1 cubed is 1 minus 1 minus 1, 0, 0 cubed, 0. So this becomes 1. So this is the value of the expression when k is 1. Now, what is the value of this expression when k is 2? When k is 2, this becomes 2 cubed minus 2 minus 1 cubed. And what is this? 2 cubed is 8 minus 2 minus 1, 1 cubed, that is just 1. So 8 minus 1, that is going to give us 7. Let's go to the next value. When k is 3, the value of the expression will become 3 cubed minus 3 minus 1 cubed. 3 cubed, we know that is going to be 27, minus 3 minus 1, 2, 2 cubed, that's 8. So 27 minus 8, that is going to be 19. We move on. When k is 4, the expression is going to be 4 to power 3 minus 4 minus 1 cubed, right? What is 4 cubed? That's obviously 64, minus 4 minus 1, that is 3. 3 cubed, that is going to give us 27. And what is 64 minus 27? That sounds like 37. So that 7 plus 27 is going to give us 14. Carry on. Yes, it's 37. Okay, so these are the values of the expression for the different values of the k. But remember, I told you that the connection between these values when using the summation operator is the plus sign, right? So this means when n is 1, we only summing k is equals to 1. So when n is 1, the value of the summation will be 1. When n is 2, we need to sum for k equals to 1 and k equals to 2. So we sum 1 plus 7 and 1 plus 7, that is going to give us 8. When n is 3, we now need to sum for k equals 1, 2, and 3. So that's the same as just taking the value we had for 2 plus the value for 3 here, and that is going to give us 27. When n is 4, it's the same as summing the values when k is 1, when k is 2, when k is 3, when k is 4. So it's the same as taking the values for when k was 3, then plus the values for when k is 4, and that's 27 plus 37, which is going to be 64. But I want you to notice something up to this point. What is this? 64 is 4. Okay, let me actually use the equals operator. 64 is 4 to power 3. 27 is 3 to power 3. 8 is 2 to power 3. And 1 is 1 to power 3. Are you seeing the pattern here? This means that all this summation is literally the value of n to power 3. Yeah, literally. So all that scary expression now collapses to, okay, actually let's just write, therefore the summation where k is equals to 1 all the way to n of this expression k cubed minus k minus 1 cubed collapses to n cubed, just the value of n, and you cube that. So that's it. Now the left side of the expression is n cubed, so we know that n cubed is equals to, then we go back to our equation. So we had 3 times the summation of k squared, so 3 times the summation k equals to 1 all the way to n of k squared, and then minus 3n n plus 1 3n n plus 1 over 2, then plus n, Okay, so obviously we say, wait, did I miss a 3 somewhere? Yeah, I missed the 3 on the 3k squared. Yeah. Okay, so remember that we said our interest is in this, right? So what we are going to do is we are going to take all the other terms and we take them to the left side. So this means that on the left side, we currently have n cubed. When this minus 3, this whole expression comes to the left, it becomes positive. So it will be plus 3n n plus 1 all over 2. Then positive n comes to the left, becomes minus n, and we are saying this is equals to 3 times the summation, where k is equals to 1 to n of k squared. Now, since our interest is in simply like the summation of k squared, let's remove this 3, and we are going to remove it by dividing each of these terms by 3. So when I say divide this by 3, then on this side divide this by 3, and on this one dividing by 3 is simply the same as multiplying by a third, and then on this one we divide by 3. So this becomes n to power 3 over 3, and then plus, so here we have 3 over 2 times a third. So we have 3 over 2, and we are multiplying that by a third, by 3, 1, by 3, 1, and this is going to give us a half. So it's basically having n plus 1 and over 2. And then here we're only going to have n over 3, and all this is equals to by 3, 1, by 3, 1. This is equals to the summation from k is equals to 1 to n of k squared. Okay. Now let's rewrite this starting with the right side. So basically this means that the summation from k is equals to 1 all the way to n of k squared is equals to n to power 3 over 3, and then plus, so let's expand this, n times n, that's going to be n squared, n times 1, that's going to be plus n over the 2, and then minus n over 3. So we've just basically rewritten what we had up here, like starting with the left side. So I mean starting with the right side. Okay. Now this means that this is equals to n cubed over 3, then plus, this is the same as doing n squared over 2 plus n over 2, since they have the same denominator, and then minus n over 3, right? This is equals to the summation of k squared from k equals to 1 to n. Now these two have the n, right? So it means we need to find their LCM. So the LCM of 2 and 3 is 6, right? 6 divided by 2, that's 3, times n, that's 3n, minus 6 divided by 3, that's 6 divided by 3, that's 2, 2 times n, that's going to be 2n. Then we have plus n squared over 2 plus n cubed over 3, and this is equals to the summation of k squared from k equals to 1 all the way to n. So what is 3n minus 2n? That's going to just be n over 6 plus n squared over 2 plus n cubed over 3, and this is equals to the summation from k is equals to 1 to n of k squared. And there we have it. So this means that To find the summation of k squared from k squared is equals to 1 all the way to n, all you need to do is do n to power 3 over 3 plus n squared over 2 plus n over 6. And let's take this for a spin to ensure that we got it right. So we are going to find the sum of the squares of the first 5 integers from 1 to 5. So we basically want to find 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, right? So let's first of all do this manually. So 1 squared is 1 plus 2 squared, that's going to be 4 plus 3 squared, that's going to be 9 plus 4 squared, that is 16 plus 5 squared, that is 25, right? So let's start adding them up. 1 plus 4, that gives me 5. Then I do the 5 plus 9, which is going to give me 14. Then I'm going to do the 14 plus 16, that's going to give me 30. And then I do 30 plus 25, and that's going to give me 55. Now, let's use our formula. When we use our formula, it should give us the same answer. So in our formula, we are basically finding the summation of k squared from k is equals to 1 all the way to k is equals to 5, right? And we've said that this is going to be the value of n, which is 5. So we take 5 cubed over 3 and then plus 5 squared over 2, 5 squared over 2, and then plus 5 over 6. Okay, let's expand this and see if we get the same answer. So 5 cubed is 125 over 3 plus 5 squared, that's going to be 25 over 2 plus 5 over 6. Then what is the LCM of 3, 2, and 6? That is 6. 6 divided by 3, 2. 2 times 125, that's going to give us 250. Plus 6 divided by 2, that's 3. 3 times 25, that is going to give us 75. And then plus 6 divided by 6 is 1. 1 times 5, that is just 5. Okay, so what do we have here? 75 plus 5, that's 80. 80 plus 250, that is the same as 330. And then over 6. So now we have to do 330 divided by 6. I'll just do it manually. So 330 divided by 6, this is going to be 5 because of 30, then 30 again, so 5 because of 30. And there we go. So we get 55. Now, see, the two are identical. So this means that our formula is indeed correct. Okay. Now that we have the formula, like we can sum from k to 1 to n of k squared, and we are saying this is the formula, we now go back to the question, right? And in this question, we are only looking for the values up to 1000. So this means that, let me change the color there. So this means that the summation of k squared from k is equals to 1 all the way to k is equals to 1000 will be, we go back to our formula, so we take the n, in our case the n is 1000, right? So we take n cubed over 3 sorry, so we take 1000 cubed over 3 plus n squared over 2, so plus 1000 squared over 2, then plus n over 6. So n still 1000 over 6, right? And this is the same as 1000 cubed is just taking the 1 and then adding the 3 zeros 3 times. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3, right? So that is 1000 cubed. This is all over 3, then plus 1000 squared, that's going to be 1, 2, 3, 1, 2, 3. This is all over 2, and then plus this is still 1000 over 6, right? And then of course, at this point, you can choose to use a calculator. I think I can just do this manually. So this becomes the LCM of 3, 2, and 6, that is 6. So 6 divided by 3, that's 2. 2 times 1 billion, that's going to be 2 billion. So 2, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then plus 6 divided by 2, 3. 3 times 1 million becomes 3 million. 1, 2, 3, 1, 2, 3. And then plus 6 divided by 6, 1. 1 times 1,000, that is just 1,000. And then we can just do 2 billion, 1, 2, 3, 1, 2, 3, 1, 2, 3, plus 3 million, 1, 2, 3, 1, 2, 3. We have the 3 there, and then plus 1,000. So when we add all this, we get 1, 2, 3, 0, then 1, 2, 3, then we have the 3 there, then actually after the 3 we have 2 zeros now, and then the 2. So all of this is just the same as taking this big number 1, 2, 3, 1, 2, 3. What? I think I got this wrong. Did I? Let's see. Oh, the comma is supposed to be, yeah. I've mistaken my commas here. Okay, maybe I should have just used a calculator, but oh well, here we are. So, oh god. Okay. So the one was supposed to be here. Yeah. So that, okay, so that means the answer is also a bit wrong here. Actually, let me just do this all over again. So this is we have 1, 2, 3, 0, 0, 3, 0, 0, 2. So basically it's this number 0, 0, 3, 0, 0, 1, 0, 0, 0 divided by the 6. And I think I know better. I'll just use a calculator for this. Oops. Okay. So we are doing 2, 1, 2, 3, 0, 0, 1, 1, 2, 3, and we are dividing this by 6, and that's going to give us 3, 3, 3, 8, 3, 3, 500. 333,833,500. This is the answer to the question. So thanks for watching, and I really hope you learned something new today.